Hello, my name is Sundaresan Manoharan. This is my final project presentation. The topic I chose is Sqoop, a mechanism for transferring data to and from HDFS. The motivation for the project is relational data stores has been a mainstay for many major corporations for the last 20 years. However, with the tremendous growth of data doubling almost every 2 years, the capacities of enterprise data warehouse are being exhausted. Load processing windows are also similarly being maxed out, adversely affecting services and threatening the delivery of critical business insights. The need to store infrequently used just-in-case data exacerbates this challenge by taking up expensive capacity. Also, we have three big V problems: volume, variety, and velocity, which are in turn driving up the cost of data warehouse, ETL processing, and analytics. Relational data source can no longer handle the growing breadth and depth of analytic workloads. And most of the relational data source was designed only to hold structured data sources. The cost to scale relational data store technology is high and eventually becomes prohibitive. Even if the cost could be justified, the performance would be insufficient to accommodate today's growing big data problem. The most scalable and cost-effective data store is needed, and Hadoop satisfies both of these needs. Typical traditional data source has many bottlenecks. The data source are conceived mainly for MBs and GB size of structured data, and the data is structured based on the transaction and expected collision analytics. And the workloads are also distinct based on the type of data: transactional, transformational, and BI analytics. And it has poor load and query performance, and it takes a lot of time to backup and recovery operations, and it needs very expensive data administrative tasks. On top of that, we are getting hit by big data. The data is growing in volume and complexity, and today's use cases needs more and richer data, and the data retention mandates policies forces hard decisions, and the ETL patch windows are bursting, and EDW straining to accommodate volume and varieties of data. And it's all increasing cost of ownership per terabyte. So typically, people follow the ETL process, which is extract, transform, and load to the data warehouse for any to perform advanced analytics. For years, organizations have struggled to scale traditional ETL architecture to keep up with the three V's of city. And then people move to ELT mode, which extracts loads without transforming and then transforms only when needed. And then Hadoop eliminates both ETL and ELT bottlenecks. It is inexpensive storage, and it gives a low cost to eliminates trade-offs, contingencies, and it's very flexible. Typically, any organization have data and which can be classified into three categories: hot, warm, and cold data. Hot is more frequently accessed data stored in faster storage. Warm data less frequently accessed, stored in slightly slower storage. Cold data, which is rarely used data, stored in slowest possible option. Majority of the data in traditional data stores are unused and dormant data. ETL and ELT processes for unused data unnecessarily consuming CPU capacity, dormant data consuming unnecessary storage capacity, load and store unused data for active archival in Hadoop. So where we can store in Hadoop? So Hadoop is meant for many different purposes. So one of the use cases, we can offload the cold dormant data, the just-in-case data, and any archival load. And then we can also use it for ELT type of load, which is used for analytical platform. And Hadoop can also hold the other type of data, which is social media data, unstructured data, streaming data, sensor data, and log and event streaming data. So the use cases I took to demonstrate is offload data from relational data source. So this is an example of ELT process similar to the ETL process. To load data warehouse, however, instead of transforming data before loading into the data warehouse, we will extract from MySQL using Sqoop import and load it as is into the HDFS, and then make the data available for any further analysis. And then the result of this analysis, data it's produced, load it back to the MySQL. So why Sqoop? So Sqoop is an open source project from Apache Foundation, and it is a command line interface application for transforming bulk data between relational database and Hadoop. It supports incremental loads, and it also supports freeform SQL query to extract data from relational databases. And you can save the Sqoop jobs, which can be run multiple times to import updates made to a database since the last import. Imports can also be used to populate tables in Hive or HBase. Export can be used to put data from Hadoop into relational databases. So let's look at the Sqoop architecture. Sqoop primarily does two things, import and export. The import functionality reads the metadata from the relational databases, and it slices the data by its primary key minimum and maximum value, and then it submits the map only task to execute each slice in parallel. Each mapper then reads the data from the relational and writes the data into the Hadoop, HDFS, Hive, or HBase. In the similar fashion, export functionality reads the metadata from the relational database, and it reads the data from the HDFS directory, and based on its operations, it writes insert or update statements to load the data back to relational database. So let's look at the Sqoop import function a little bit in detail. So Sqoop import function can import data from an entire table from the relational, or it can read specific columns, or it could read the specific rows like var class. You can mention where exactly to write the data in the HDFS folder or in a Varos folder. You can instruct to delete the target directory before it writes, and then you can also write it in different output formats like text, sequence file, or Avro. Sqoop can use direct load if the native connector has that functionality, and it can also has a mechanism to control the parallelism. You can control the number of mapper tasks, and it can also compress the output data before it writes, and it supports a freeform query, and it can import all table at once. So look at this commands. So it takes the Sqoop import, and then the connect parameters takes the GDBZ driver. So in this case, it is a MySQL. It connects to the employees database, and then you give the username and the password, and then mention the table which you want to extract the data from, and then mention the target directory in the HDFS where you want to write the data, and then it reads and writes into the HDFS folder. And similarly, you can write your own SQL query and then mention your target HDFS folder. It writes map task to transfer the data in parallel. Sqoop incremental. Sqoop can also support incremental data, which is delta data. So it has like two modes. One is append and the other one is last modified. The append will find any newly added rows based on the check columns you specify and the last value you supply. And then last modified, it finds any updated rows, which is a timestamp column, and then you provide a timestamp value, and based on that it will find all the records which are updated after that particular timestamp. And then Sqoop export, it transfer entire or subset of the data from HDFS back to the relational database. So it can do the entire table, or it can load only specific columns, or it could also use the direct option if available from the connector. In the export also, you can control the parallelism using the number of map tasks you want, and it can insert the data, or it can update, or it can do an upsert option like insert when it's not available and update when the data is already available in the relational database. And it can also use the batch load, which is like instead of executing every insert or update statement, you can update bulk in a batch mode. And export option also uses the staging table to make sure the transaction is complete. It uses the staging table first to load every data from HDFS to relational, and then once it is successfully moved from HDFS to relational, and then it moves from staging table to the actual table. And then Sqoop can also load the data into Hive and HBase, so which gives more functionality. The Sqoop can directly import into a Hive, and it can override the table if the table is already exist, or it can create the Hive table if the table is not present. And you can mention the column mapping specifically to support Hive data types, and it also supports the Hive table partitions. The Sqoop also supports the HBase column-oriented NoSQL database in HDFS, and it imports the data directly to the HBase, and it can create the table in HBase and it supports the HBase bulk load options, and you can set the column family for the import. Using Hadoop and Sqoop, you can do many use cases. The one I demonstrated is a very small use case, and you can build a heavy ETL engine where you extract and all your sources into Hadoop and then build your enterprise data warehouse, or you can build the data mart, and then on top of that you can build your BI solutions. Similar fashion, you can do a tiered data warehouse architecture where you extract all your sources into Hadoop, and then you build department specific data warehouse or data marts, and then build a BI solution on top of it. Or it's very common use cases building an analytical platform where you load all your sources into a Hadoop, and then you do exploratory data analysis or run any machine learning algorithm, and then build a BA solution on top of it. So by doing all this, we get many benefits. So few of the major benefits are more cost effective compared to the scalable solution available in the market, Teradata appliances, Oracle Exadata, or IBM Netezza. The Hadoop gives 30 to 50 times more savings. It gives more retention period. Hadoop can hold both structured and unstructured data in one place, which in turn gives an opportunity to do more extended analytics using MapReduce and NoSQL technologies. So the lessons learned. So Sqoop, even though it does a lot of good things, it does have some challenges. It is a cryptic contextual command line argument. So you need to make sure you give your command line arguments in the right order, in the right way. So otherwise it will fail. And it also has a security concern where credentials are shared openly. And then type mapping is not clearly defined. You have a different type of mapping for Java and different type of mapping for Hive, and sometimes not all data types are supported. And client needs access to Hadoop binaries and configurations and databases. And the JDBC model is enforced. So you have to use the JDBC and the database which supports the JDBC model. And it also has some non-uniform functionality, which is like different connector supports different capabilities. And also it has some overlap to duplicated functionality. Different connectors may implement the same capabilities differently, so the performance of different connector. High coupling with Hadoop, meaning that it is highly dependent on Hadoop. Any database vendor required to understand the Hadoop in order to build their connectors. So what's next? So Sqoop comes with the Sqoop tool, which takes care of most of the Sqoop 1 drawbacks. And Sqoop 2 is a client-server based architecture. So you install the server and configure everything in the server side, and your client can talk to via the server. And it comes with client interface, command line interface, and then web interface, and also REST API. And the server is has the access to Hive and HBase, and the connectors are not restricted to only the JDBC model. And also it has a role-based security. And then it also comes with the resource management policies. You can control how much resource it can take. So in summary, Sqoops gives a lot of functionality to offload or to move your data from the expensive storage on the relational side to the most cost-effective Hadoop platform, which will open up a door to do more extended analytics and less cost-effective storage options like archival, backup. And also you can seamlessly integrate with your other data sources like social media data, unstructured data, and your other streaming sensor data, and do a extended analytics, and which will help your business. Thank you.